Okay, today we're going to continue learning how to solve equations. These equations are going to be a little bit more complicated than the ones that we solved last time, but still fairly simple as equations go. And we'll take it step by step, getting more and more complicated as we go along, and before you know it, you'll be solving some pretty complicated looking equations. So let's just start out with something fairly simple that looks, let's just say like this: 5x minus 1 equals 4. Okay, this is very similar to the type of equation we did last time. Now notice what you have. Basically you have 5 times a variable x. This whole quantity, this thing that's multiplied together, you subtract 1 from it, and then the result of that must equal 4. There's only one value of x that'll do that, and that's what we're trying to solve for. So notice the order in which this is done. If you were to punch it in your calculator, you would take 5 times x. If x were 5, for instance, you'd take 5 times 5, you get an answer, and then you subtract 1, and that would be the result. So you're doing the multiplication first, and then you're doing the subtraction. And so we want to isolate x on one side of the equal sign, and so we'll just do it in stages. We don't want to do it all at once, we'll do it in stages. So first let's get rid of this 1. Here. We can get rid of that 1 by simply adding 1 to both sides. I've got a minus 1, so if I add 1, that'll make a 0 on that side, and I have to do it to both sides. So let's just say 5x minus 1 plus 1 is equal to 4 plus 1. Okay? And this is the last problem that I'm going to, one of the last problems that I'm going to explicitly show it this way. But you can see this goes to 0 because 1 minus 1, 0, or negative 1 plus 1, 0. And of course this is going to be 5. So we're left with 5x on the left equals 4 plus 1 is 5 on the right. So we've successfully stripped away part of the left side of the problem. Now we want to get, all we have to do is get rid of this 5 here, over here, and then we get x by itself, and then that's the answer. In order to do that, I'm going to divide both sides by 5. So I'm going to divide this side by 5, and then I'm going to divide this side by 5. Okay? 5 divided by 5 is 1. 5 divided by 5 is 1. So x is simply equal to 1. And that's the answer. And you can plug that in. You can plug this answer in. If x is equal to 1, we'll just plug it right back in there. 5 times 1 is 5, minus 1 equals 4. And that is the value of x that will solve that equation. Okay, great. Let's continue. Let's take something that looks very similar. 6x plus 2 is equal to negative 4. Okay. Now, I kept writing, you know, for instance, right here we have 6x plus 2. So we need to subtract 2 from both sides. We're doing the opposite. We subtract 2. I could go ahead and write, you know, 6x plus 2 minus 2 equals, and then 4 minus 2, but you know, every single time you do that, all you're going to do is drop away the 2. So I'm going to kind of omit that from here on out, and that's the way that you'll really see it in a lot of the problems. So I'm just going to skip one little step, one minor step, and say 6x is equal to negative 4 minus 2. Now I want you to study that and make absolutely sure that you understand what I did there. What I did between this step and this step is I said 6x plus 2 minus 2 is equal to negative 4 minus 2. And these equations, when you do that, every single time you do that, this is going to go away to 0. Every time. That's the point. That's the reason you're doing it. So as long as you keep the signs right and make sure that you're doing the opposite on the right hand side, you're good to go. And you can just kind of imagine yourself kind of moving this over here, but just putting an opposite sign there. So this is what we have to work with. And of course minus 4 minus 2 is equal to minus 6. Negative minus a negative is a negative, and then 4 plus 2 is 6. So what I have is 6x equals minus 6. And again, I want to get x by itself. So in order to get x by itself, I've got it multiplied by 6. So the opposite of that is dividing by 6. So I'll just divide by 6 here, divide by 6 here. So x is equal to negative 6 over 6 is negative 1. And you can go back to your fractions section and see the reason why. Negative divided by positive is a negative, and 6 divided by 6 is 1. And again, here I'm going to refrain from showing this every single time what I'm doing here. I've just divided by 6, but again, the 6's kind of go away and leave you with a 1, an implied 1. It's very important to understand the concept behind what you're doing there, but you need to get used to dropping that notation, because all it's going to end up doing as you go through your algebra here is cluttering up your equations. So let's practice these ideas on this problem. 3x minus 8 equals 1. I want to get rid of the 8 first. I've got a minus 8 here, so I need to add 8 to both sides of the equation. So I'm going to carry 3x down. I'm going to add 8 to this side, which makes this negative 8 disappear, equals 1, and I've got to add 8 to the right-hand side of the equation. Now remember, I've added 8 to both sides, but because I've got this negative 8 here, it just drops away, it disappears, poof, it's gone. Okay? And this, of course, is equal to 9. So what I have is 3x equals 9. And in this case, in order to get x alone, I need to divide both sides by 3. When I do that, when I divide this by 3 on the left-hand side, the 3's are going to disappear. Remember, that is the whole point. I'm dividing by 3 is to make the 3's disappear so that I'm left with x. So I'm just going to say x is equal to, I'm not going to do the 3 over to the 3, I'm just going to write x is equal to 9 divided by 3, because I have to divide both sides by 3. On the left-hand side, the 3's disappear. This is simply equal to 3. And that's the answer. And if you want to check this, that x is equal to 3, the one and only value that will make this equation true, you can plug it in. 3 times 3 is 9. 9 minus 8 is 1. So you see, we're just doing things in reverse order. And in fact, with these equations, they're fairly simple. You could probably stare at them long enough and get the answer, but trust me, in the near future, we will be working some equations, even in this section, that are going to be too complicated for you to do in your head. So let's move on and do one that looks like this. Let's say we've got 2y minus 5/3, I've got a fraction in there, equals 4/3. Okay, there's a couple different ways to do this, but it's the same thing. I just got a fraction instead of a number. I need to first get rid of this 5/3 business up here, okay, to get 2y by itself. So in order to do that, since I've got minus 5/3, I'm just going to add 5/3 to both sides. On the left-hand side, it's going to make that disappear. So I'm going to be left with 2y equals 4/3, and I need to add 5/3 to it because I'm adding 5/3 to both sides. And you remember how you add fractions. When you've got a bottom number that's the same, you add the top. 4 plus 5 is 9, and you keep the bottom, which is 3. In this case, 9 divided by 3 is simply 3. So when you really boil it down, you're left with 2y is equal to 3. And in order to get y by itself, I'm going to simply, since I have it multiplied by 2 here, I'm simply going to divide by 2. When I divide by 2, the 2's are going to disappear here. So I'm going to be left with y is equal to 3 divided by 2, because you must do that operation to both sides. And this is the answer. And if you were to take y and put it in there, you'll see that when you play with the fractions that it does indeed satisfy that equation. So, like I said, it's like playing checkers. Once you know the rules, it really is not that big of a deal. Let's say I have something like this. X over 3 minus 3 is equal to minus 2. Now this is a slightly different form. And the problems that we've been doing before, we've had like 2x, 3x over here, minus or plus something is equal to something. This is a little bit different, but it's really going to be no sweat. The bottom line is I want to get rid of this minus 3. The goal is to isolate x. I want to get rid of this minus 3. How do I do that? I got to do the opposite. The opposite of subtraction is addition. So I add 3 to both sides. That's going to leave me with x over 3 on the left equals minus 2 plus 3. I added 3 to both sides. It made the 3 disappear over here because minus 3 plus 3 is 0. And I'm left with the minus 2 plus 3 over here. If you add that, you can convince yourself that's equal to 1, because I'm adding a negative in the positive. The bigger number is positive, so the sign is going to be positive, and then 3 minus 2 is 1. So I'm left with x over 3 is equal to 1. Now, on the left-hand side, I've got x divided by 3. I want to get x by itself. The opposite of this division is simply multiplication. So since this is the first of this type, I'll just explicitly show what's going on here. I'm going to multiply both sides of this equation by 3. 3 times x over 3 equals 1 times 3. All I've done here is multiply both sides by 3. And because I've done that, this 3 goes out with this 3 and makes a 1. 3 divided by 3 is 1. 1 times 3 is 3. So x is equal to 3. So I'm not going to show that anymore. I mean, what I'm doing here, I'm multiplying by 3, and instead of showing this part of it in every single step, I'm going to kind of omit that. But you definitely need to keep track of what's going on the right-hand side. You just need to know what operation you're performing in order to isolate the variable, and then do that to the other side of the equation. So not too bad so far. Let's say I've got, let's do one very similar. Z over 9 plus 5 equals negative 1. I want to get rid of this 5 first. Okay, so I'm going to subtract 5. So I'm going to be left with 0 over 9 is equal to minus 1 minus 5. I've subtracted 5 from both sides, and that got rid of the 5 here. This is equal to negative 6. You should be able to convince yourself of that. Minus 1 minus 5 more gives me minus 6. So I'm left with z over 9 is equal to negative 6. Okay? And now in order to get z by itself, I'm going to do the opposite of this division, which is simply multiplying by 9. When I multiply by 9 on the left, the 9s are going to drop out, and I'm going to be left with times 9 on the right. So you're going to be left with z is equal to minus 6 times 9, which is negative 54. And that's the answer. And if you plug that in, you'll see that that's the answer. So hopefully working through all these problems, problem after problem after problem, will make it just crystal clear what we're doing. Okay, now let's do one a little bit different. Let's say we have k over 5 minus 1/2 is equal to 3/2. Okay. The first thing we need to do is get rid of this 1/2. I want to get the k over 5 by itself, so I'm going to add 1/2 to both sides. That's going to leave me with k over 5 is equal to 3/2 plus 1/2. I'm adding the opposite here. And this is just going to be equal to 4/2. 3 plus 1 is 4. You leave the 2. This is simply going to be equal to 2. So I've got k over 5 is equal to 2. In order to get the k by itself, I've got to do the opposite of this division, which is multiplying by 5. It's going to isolate k by itself. So k is equal to 2 times 5, which is 10. And that's the answer. 10 is the answer. Now remember, on the left-hand side, I'm not explicitly showing what's going on, but when I take k over 5 and multiply by 5, this simply cancels and leaves me with a 1. That is what allows you to do this. That is the entire reason that this even works, is because when you do the opposite here, you kind of allow things to drop out of the equation, and that kind of helps you simplify things. Okay, let's do this one. This is kind of an interesting one. Let's say I've got b plus 5 over 3 is equal to 11. Now this is a little bit different than what I've done so far, but the goal is the same: get b by itself. Now notice the order in which we would do this if we were using our calculator. We would take b and we would add 5 to it first, and then we would get that answer and divide the whole answer by 3. The way you know to do that top part first is because the entire thing is divided by 3. So you must, it's almost like there's parentheses around here. So you want to do the top first, you'll get the answer, and then you'll divide. So in order to isolate b, we kind of want to unwrap this present on the left. We want to unwrap this box in reversed order. So the first thing we want to do is get rid of this 3 on the bottom. There really isn't much you can do with this 5 yet because it's kind of wrapped up here. It's over a fraction. It looks kind of goofy. But you can get rid of the 3. And since this whole thing's divided by 3, the way you get rid of the 3 is by multiplying by 3. And if you multiply this entire left side by 3, the 3's are going to cancel. So they're going to disappear. So you're going to be left with b plus 5 is equal to 11 times 3, which is 33. Now remember, I've multiplied both sides by 3, and then it allows the 3's to drop out because 3 divided by 3 is 1. So now to get b by itself, it's very simple. I've got b plus 5 equals 33. To get b by itself, I simply subtract 5 from both sides. That means the 5's are going to go away because 5 minus 5 is 0. So b is equal to 33 minus 5, which is equal to 28. And that is the answer. So again, this looked a little bit different, but as long as you know the rules and kind of the point and kind of what what's going on, you can do most any kind of equation like this. And that's why we're doing so many examples, to kind of show you how to apply it to different kinds of problems. Let's do one more that's pretty much almost exactly the same. Let's say it's u minus 2 over 5 equal 1. I want to get u minus 2 by itself, so I'm going to drop this 5 out. How am I going to drop the 5 out? I'm going to multiply both sides by 5 to get rid of this because this is being divided by 5. That's going to leave me with u minus 2 is equal to 5 times 1 because I'm multiplying both sides by 5. And that's going to equal 5 on the right. So I've got u minus 2 is equal to 5. Okay? So it's very simple. And then in order to get u by itself, I've got to get rid of this 2. So since I'm subtracting 2, I'll simply add 2. So that will mean u will equal 5 plus 2 equals 7. Again, I've added 2 to both sides. It's just that on the left, when I add 2 to negative 2, it goes away. It disappears because 2 minus 2 is 0. So when I add 2 to the right-hand side, I get 7. And that is the answer to the problem. Okay? Let's move along, and let's do one that looks like this. This is kind of interesting. Let's say I have 3x minus 2 minus 6 equals 9. Okay? The first thing I want to do here, I really can't do much with the 3 or the 2 because I've got this 6 hanging out here. I want to get rid of the 6 by itself. How do I get rid of this negative 6? I add 6. So 3x minus 2, haven't touched that yet, is equal to 9 plus 6. I add 6 to both sides. The 6 on the left drops out, and I add 6 on the right. This is equal to 15. Okay? Equal to 15. Now, in order to get the 3x by itself, I got to get rid of this 2 first. So in order to get rid of this 2, I simply multiply both sides by 2. That's going to leave me with 3x is equal to 15 times 2, which is 30. And then in order to get this x by itself, I need to get rid of the 3, and so I divide both sides by 3. That means x is going to equal to 30 divided by 3 is equal to 10. This is the answer. Now before I blaze forward and just and say that's the answer, let's just go through it real fast. I mean, it is definitely the answer, but let's just look at it. We wanted to get rid of the negative 6, so we added 6. Minus 6 plus 6 is 0, so this term dropped out, so I carried the 3x over 2 down, added 6 to the right, I was left with 15. So I had 3x over 2 is equal to 15. Then I wanted to get rid of the 2. The opposite of this division is multiplication, so I multiplied both sides by 2. That completely eliminated this 2 because after you multiply by 2, 2 divided by 2 is 1. So I was simply left with 3x on the left is equal to 15 times 2, which was 30. Then finally I wanted to isolate x, so I wanted to get rid of this 3, which was being multiplied, so I simply divided both sides by 3. That got x by itself, and then 30 divided by 3 was 10. So it's very much going in reverse order. I got rid of the 6, then got rid of the 2, then got rid of the 3. You just kind of work at it step by step by step. The real trick is just don't get hung up on trying to do it all at once. You just start somewhere. You know how to get rid of the 6, so go ahead and get rid of it. Then you'll look at the next step and you'll say, well, I know how to get rid of this too, so I get rid of that. Then finally you're left with the final thing, and it's not so big of a deal. But don't try to tackle it all at the same time. Let's do one more like that. 3y over 2 plus 5 is equal to 11. So you look at this and you say, I want to solve for y. I know how to get rid of this 5, so let me do that. I'm going to subtract 5 from both sides. Once I subtract 5 from the left, all I'm going to have is 3y over 2, because this 5 is going to go away. That's going to equal 11 minus 5, because I have to subtract 5 from both sides. This is going to leave me with 6. Okay? So I've got 3y over 2 is equal to 6. Now, I know how to get rid of this 2 because it's being divided, so I just multiply both sides by 2. That's going to leave me with 3y, 2 is going to disappear, equals 6 times 2. That's simply 12. And then you're like, oh, I know how to get rid of this 3 right here. I simply divide by 3. That's going to leave me with y equals 12 divided by 3, which is 4. That's the answer. And if you want to check it, y is equal to 4. We have proven, if you believe this stuff, that this is the only value of y that will make this work. 3 times 11 is, 3 times 4 is 12. So that's 12 on the top. 12 divided by 2 is 6. 6 plus 5 is 11. So that is the one and only answer that will make this equation true.